condition overall, and that condition is if in any subject is over 75. So we'll say and this is greater than 75. This again is greater than 75. This is greater than 75. And it's a true. Here, sorry, where is it giving us false? Let's check what's happening. This student has a 43 in English. Let's put 80 here. That's not going to change anything because it's only one entity. All these are false. So it will give us a false. So for an end condition, all the conditions that we are going to put inside, they should be true. Then for the or, if any one of the conditions is true, the result is true. And it's only false when everything is false. Right? So that's it. Then we have the if statement. Right? Right. So we have the if and ifs. Right? So the if, it only takes one argument. The ifs, you can put many arguments there. Right? So for example, in this case, we want to check if the grade in A, if M is greater than or equal to 75, it's an A. M is greater than or equal to 65, it's a B. Greater than or equal to 50, it's a C. Less than 50, this student is sleeping in class. Okay, let's drag it down. So it gives you the result. Here, it's 65 on math, so it's a B. 80. So the ifs condition, it allows you to put multiple conditions inside, unlike the if. In the if, you can only put one condition. But for the ifs, it's like a nested function when you can put multiple conditions. Right? Let's do for science. Grade here equals to if this is greater than or equal to 85, then it's an A. Maybe you can do this while at least you are doing your data aging analysis, or you are doing your grouping. Then if this again, is greater than or equal to 60, that's a B. If this is less than 60, that's a C. Then you can close. Okay, we need to put parentheses because these are not numbers. The codes. So yes, it's less than 85, so it's a B. This one is greater than 85, so it's an A. Here it's less than 60, so it's a C. So ifs, they help you that much, and I expect that you all know the if condition. There's a hand, Feli, you can shoot.
Okay, on your formula for science, I saw put it the sequence was the same, greater than or equal to, but on the last part you said less than. So and say
Okay, so this is what the formula is doing. We have started at 85, right? So everything that is greater than or equal to 85 is an A. Everything that is greater than or equal to 60, it's a B. And everything that is less than 60 is a C. Is there any range that's not covered there?
Oh, okay. So meaning if someone gets like 20, it's a C. 50,
Yes.
it's a C. All right.
Yes.
Okay.
But we can even include to say this. It's a C. So you see what's now happening here. If I include another condition here, so it's starting here, it's evaluating 85, and everything that's below is being captured by here. But if I now repeat this, it's already being taken care of by 60. So it's being overridden by that one. So this one won't work. So all the ranges are covered.
Okay.
Unlike here, they are using, but they are saying less than, greater than or equal to, greater than or equal to, greater than or equal to, then less than. So which means if you want to put another layer where we put C and fail, we have to maintain the greater than or equal to, greater than or equal to 50 here. Then we would say this less than 50, then it's a fail. So in this way it now works. So you have to maintain the level up until a position where you want to capture now the exception. It should reverse the order.
Okay.
Where you want to capture the rest, which everyone is following in these categories. But if it's not meeting any of these, it should fall in that category.
Okay, well understood. Thank you.
Okay. So right. We want to use if or, right? Let me remove these formulas. We want to use the and if nested for functions. These ones are important. I use these every day. So, right. We want to check. So let's start inside. Let's put our end. This is greater than 7.5. This one is greater than 7.5. So we said this gives us a true, right? A true false. It gives us a true false. Right? So we now want to check if the student passed with a distinction. So this is giving us a true false. So we now come if this is true, then what? Passed with key, else failed. Else failed. Fail. If right. So if this is true, so it's checking if that is true, then passed with a distinction, else failed, repeat. So it's powerful that you can combine these formulas. The first one is checking if it's true. Then if it's true, and it's checking if it's true and it's giving us a result of true, then that one is checking if it's true, then it's giving us the condition. So you can combine all those. I think that's it. We can use an or. Like I said, an or is checking if one of the condition is met. If met, then if any one of them is meeting the condition, then it's a true. Else it's a false if all of them are false. So here it's checking if any one of the marks is less than 35 to give us a fail, else it's promoting to next class. So that's if and ifs, then your logical operators or and the end function. Then we can go to the count ifs. Count if the conditions that you have to put are true. Count if. So as you can see, it only takes into account one criteria only. But I usually like to use the count ifs. Count ifs count ifs count if, sum if, average if, mean if, max if. As long as it's a singular, it accepts only one argument. But if there's an S, it accepts as many arguments as you can. So it's usually good to use count ifs. But the disadvantage is if you have many of these formulas in your workbook, that workbook is going to be bigger and it's going to be very slow. So use it sparingly and maybe try to find other means to do it. So let's right. Right here. Maybe now we want to do our tally table. Maybe you are doing your loans analysis, your Basel 2 or your IFRS 9, where you are doing the loans are graded maybe A to E. And maybe you are doing your debtors aging analysis or your suppliers aging. You want to see how many are falling in each band. So here we want to count students in maths who have a grade A. Right? So say count ifs In maths, this is it. Yo. Okay. This, here, what I want to do is, I want to be changing my formula as I drag to this side. Maybe I wouldn't want to log this. So I'll leave it like that. Then I want to count everything that is that column that is equal to A. So when I want to drag it to the right, I will log this. Right? For maths, it's saying there are 3 A's. Let's do manual count. 1, 2, and 3. And it's getting it right. Let's drag the formula down. How many B's are there? 1, 2. And how many C's are there? We have none, which is a 0. So we can drag this formula to the right. And we can drag it down as well. In science, how many A's are there? Only 1. How many B's? 1, 2, 3. 3 B's. And how many C's? 1. In English, A, 1, 2 B's, and 2 C's. Okay? Right. So that's it. So that's count if. The same applies to sum ifs. But now sum ifs is a bit different because it then takes into account the summation column. We are going to do it next. But here, maybe we want to check if maybe some student they've scored over 90 in that table array. We can do that as well. So count ifs and sum ifs. These ones are must know because obviously you should know them because suppose you don't want to choose pivot tables. You want to have summaries that you have control of. So these are your go-to functions that you should use. Okay. So sum if. Okay. Right. So here, what is this formula doing? We have a fail flag here, which is indicating whether a fail is true or false. Can put a true here. So what this formula is doing is trying to sum everything that's there where it's a false. Okay. So sum ifs. So sum ifs now you can see that it requires at least 3 arguments per each. So we want to sum. We need the sum range first, then the criteria range. This we want to sum maths where the fail is I want to log this one. Where that may be equals to L14. It's hidden there. L14, let me log. How many? 349. Okay. Let's check my F in maths. 1, 2, 3, 4. So all those first 4 are fails. So let's see what it's doing. And you can see here that the sum is 49, 349. So that's what it's doing. Can even drag it down. And a true only is 45. So it's summing for the given conditions. Are we still together, team?
Yes.
Are you not lost?
Yeah, not. I'm following.
Tanashe, it has been long since we have heard from you.
I'm trying to reach up.
But are you getting it?
Yeah, kwa zviri kuenda ndiri kuona. Think ndakazopractice zvinobuda.
Perfect. Okay, so that's it. We can do the same for science. Some ifs. Don't bother using some ifs, just go to some ifs. Because it can allow you then to change when you want to include multiple conditions. We want to sum this when maybe we can use distinction. When distinction is what? Is similar to this. So it's 113. Let's see those who have distinctions. We don't have. So it's these two, which is second and last. 45. Oh, sorry, in science. And that, which is 113. Those student 2 and student 5 for science, it's 113. So you can do that. And you can put multiple conditions. And let's go maybe to this. And let's do this exercise. And I hope and believe that if we do this, you are going to add to your understanding. Right. So here we want to do this exercise. Right. So on the if, check if a sales person met their target. Right. So we have the let's check for sales Q2. So equals to if this the sales in Q2 is greater than the target. It's greater than or equal to the target. Then we can say target reached, else kana munhu asina kudaro below target. So you can see these ones below target. This is 7,000 and 9,000. Okay. If and here we want to check if sales exceeded the target and performance rating is high. Right. So we are only giving a bonus if the person reached the target and the performance is high. So and this So let's start with the end. And this, sorry, we are using Q2. This is greater than or equal to that. So it's checking the first condition. As you can see, it's saying logical test 1. So and can accommodate many logical tests. Logical test 2, we want to check if this equals to I. So that's the end. So let's drag our formula down. We want to see. So it's a true false. Here, of course, the target was reached and the performance is high. Here, below target and the performance is, I want to check a situation whereby, yeah, like here, the target was reached, but the performance is medium. So it's false. So those conditions have to be true, right? So let's now put the if. So we want to put the if outside here. So these are called nested functions. If this, then we want to give a bonus. Else, no bonus. So initially it's evaluating what's inside. Then the if statement is taking from the inside result, evaluating true or false. Then we then pass it to the outside argument of the if statement. Okay? So that's it there. If or, check if employees from sales or marketing. So if it's from sales or marketing, that employee is customer facing, else it's back office. Maybe we want to do some grouping of our employees into categories, whether clerical staff or what. So we want to check if, so I want to write it straight away instead of writing initially. So we are writing the or. If this equals to sales, and mind you, this is case sensitive, sales, or this equals to marketing, what is value if true, that evaluation. So the if statement is now taking the input of the or statement. Value if true, then customer facing, else it's back office. Right? So you will see that any department that is not either marketing or sales is regarded as back office. IT, finance, HR, they are back office staff. So that's the if or for you. So you can combine all these formulas. Then right, this example, I think it will help you to do with better understanding. So let's go to the retail sales tracker. Suppose you have million rows of this and you don't want to use what do you call this, pivot tables and pivot charts, right? And still you want to do your analysis that you have control over, because sometimes with pivot tables and pivot charts you may not have control of the results because it's out of the shelf, it's already built there. But with these formulas you can have control. Okay, and if you are to use basic charts on this raw data, It doesn't work. So let's try to do analysis on this one. You see that here it's a date, but it's formatted as a number. So maybe we need to change it to a short date and assume these are million rows and you want to do an analysis. Suppose you want to do your analysis by region. There's a formula called unique. So unique, what unique does is it's a text function. So what unique does, maybe you want to see how many regions do you have. You just come here and highlight maybe the entire column to see how many unique items do you have. So it will pick the unique items that you have. Even let's say you want the unique snacks. Let's say you want the snacks, you say unique and you highlight the snack, the category. Sorry, the category, the product categories that you have. You have beverages and snacks, but maybe suppose it's million rows. If you were to do it, you come here, do the filtering, do a drop down to see how many items do you have, and here how many regions do you have. But this is time consuming. So a unique function, it scans the entire data set and brings in the unique items that are there. So total units sold, we want to summarize now per region. So total units sold, we can say equals to count ifs. We can use count ifs. We want to count this column when if it's equals to this. So for count if and count if, it's only 2 arguments per each criteria. We drag down and we can do a rough check. How many south are there? We have 1 and 2. So our formula is correct. Then we want now the total sales per region equals to sum ifs total sales sales and units. So firstly, let's create the total sales. Oh, we already have the sales. So let's do the sum equals to sum if we want to sum this, right? When this region is matching this. So let's log this. It only works when you have selected it as an entire block of column. So we now have it and we can format to the currents that we want. So that's it. Now you have your summary, and from this you can now even go ahead and put your charts. For example, here I would want to use the combo chart. So on the combo chart, so here on the clustered column charts, I would want this to be secondary sales, something like this. I now have my combo chart, but it's not possible to come up with a chart like this without going the route of pivot charts and pivot tables. So now I have my chart. So here I can now come and say sales by region. And remember, if it's a combo chart here, there are two axes. Axis titles. You tick axis titles. I'll say this is revenue on the left, and this is sales volume. Something like that. So you are able to represent if the sales are directly related to the revenue. That's happening there. So basically that's it. So the sum ifs and the count ifs are so much important for you to know. And instead, okay, instead of you putting only one condition, let me do, all right, it's okay. Let's do for snacks. For snacks equals to sum ifs. We want to sum our sales, right? When that by region and for snack only, and that equals to hit this one, right? And this category equals to, we can hard code this instead of referencing to a cell. Snack okay, 1,600 for snack in region east. Let's check. Do you have any snack sale in west? Snack. So we don't have, that's why we have a 0 in west. So you can actually put many conditions in the sum ifs, but rule of thumb is the first argument is your column that contains the sum range. Criteria range 1, criteria range 2, criteria. So you can put as many conditions as you want to filter your data set. But one thing is, these formulas are heavy, and they may end up breaking your Excel, but they're actually good to use. Any questions?
And I'm following.